चलिए दोस्तों शुरू करते हैं without wasting a time. Today we have this lab. In this lab we will configure the BGP route reflector with the different cluster ID. What is cluster ID? We can say it's a BGP route reflector attribute, and this attribute is used by the RR to prevent a loop. Okay, we will see how RR will prevent the loop with the help of cluster ID. In this lab, I have configured the different cluster ID of both the route reflector. For this route reflector 1, my cluster ID is 11.11.11.11, and this RR2, I'm using cluster ID 22.22.22.22, and this is the and this same IP are the loopback 0 IP address of this RR also. And we have these three cell site routers: cell site router 1, cell site router 2, cell site router 3. Okay, and their loopback at 0 address is 1.1.1 for the cell site router 1, and for the cell site router 2 we have a 2.2.2.2 loopback 0 prefix, and for the cell site router 3 we have a loopback 0 address is 3.3.3. And we have this C customized device which is connected with this cell site router 3, and between the cell site edge router 3 and this customized device we are running a eBGP. Okay, and this is the custom prefix 100.100.100.100. Okay, and all of the cell site router are peering with the route reflector. So this cell site router 3 is the client of two route reflector 1 and 2. Similar the CSS2 is also client of two route reflector 1 and route reflector 2. And similar way, cell site router 1 also is the client for the route reflector 1 and route reflector 2. Let's see what happening here is. And here all five routers we have configured the BGP AS1, and we are using an IGP integrated protocol ISIS. Okay, so we have an IGP in place. Let's see action. Let's see in action if we advertise the custom prefix. Or from this C device we have advertised this prefix 100.100.100.100 towards the on the eBGP peering towards the cell site router 3. Okay, on this cell site router I have checked the route show route 100.100. Here we can see that we are learning this route external routes from this 30.0.0.2. This is the interface address which we have configured between the this router and this router. Okay, so what will happen is once this cell set router 3 will receive this prefix from the customized device, so this will advertise this route to the route reflector 1 and route reflector 2, as we have a 2 IBGP peering with the RR1 and RR2. Okay, so here I have taken the output from the route reflector 2 for this customer prefix show BGP for this prefix which we have advertised from the BGP name from the customer side router. Okay, so I'm getting the two paths. So path ID 1 is showing this route is received from the 3.3.3. Okay, 3.3 is the IP address of this cell site router. So this cell site router advertising prefix. So this is the path number 1 is received from the CSS3. And similar way, part 2 is received from the 11.11.11, because these two are also peering with each other back to back peering their IBGP neighbor is configured. So this RR2 is also getting the one route from the 11.11.11 also. It's showing here actually in the second path number 2 received from this. Here we can see that originator ID, because ultimately this route is originated by the this CSS. So while RR1 is advertising this prefix on this back to back peering to RR2, so it's setting the originator ID also. Okay, and similar kind of output from the RR1 also you can see I pasted here. Show BGP 100.100.100. This is the customer prefix. It's coming from the two paths. One is from the direct from cell site router 3, and one is from coming from the RR2. This is the RR loopback 0 address 22.22.22. It's setting cluster list ID. Originator ID is also is 3.3.3. So we have checked on the both of the RR. There are the two path available. One from the direct from the cell site router 2, other from the back-to-back peering, which we are running between the route vector 1 and route vector 2. Okay. Let's take the example of this RR. What will happen is now this RR2 have advertised this prefix to the CSS1 and CSS2. Okay. So what we will do? First thing is it have received the two routes, correct? One is the route is coming from the this CSS3, and one is the route coming from the back-to-back peering. Okay. So once, so he will advertise this while he will advertise this route toward the CSS2 and CSS1. What he will do is it will append O1 cluster ID, okay, with this prefix. So on the path ID 1, when you go to advertise, what will do, it will put the cluster ID O1. So it will put on this path ID 1, it will put the cluster ID 22.22.22.22. Okay, similar with the second path, it will do, it will also append the cluster ID. Here the cluster ID already we have a cluster ID in place for the route reflector 1. It will add O1 cluster ID also here. Okay, after that we run the best path calculation, and he will find that path id 1 have a single cluster id length, and while the path number 2 have a two cluster id length, one from the route reflector 1 and one from the route reflector 2. So he will select the best path number 1, and this will advertise the prefix toward the css1 and css2. Okay, similar way RR1 also done the same thing. Okay, and it will also advertise the prefix which we have learned from the direct from the css3, and this will reflect it to the css1 and css2, and region is the same because the cluster id length is 1, and while we have received the prefix on the back to back link, on that prefix cluster id length with the 2 while doing the advertisement toward the css1 and css2. So this is the region. While checking the route on the css1, we have getting the two paths, one from the 11.11, okay, one from the RR2 22.22. Okay, similar way CSS2 also will receive the two prefix two path, okay, one from the reflector 1 and reflector 2, while CSS3 is receiving this path from the EBGP, but it will discard the path which are coming from reflector 1 and reflector 2. The reason behind that is, once this CSS3 will receive this prefix from the RR1 and RR2, while receive the prefix, it will found that these are the prefix have an originator ID 333. Okay, so you will found these are the prefix originated by myself only, and these prefix have an my originator ID 3.3. So this will discard. In the log also you can see that it have received the update from this prefix from the RR2 discarded local originator, and similar way it's received the update from router 1 and discarded due to the local originator is 3.3. This is the region. On this CSS3 we will see the only single entry, that is the EBGP. Okay, this is the use of, we can see that house originator ID used by the route reflector clients. What we'll do in the mission for RR1, I will show the configuration of one RR and one CSS as the configuration same for all devices. Let's go with the protocol wise. First thing we'll check the configuration of the BGP. So here I define that this is how we define the cluster in the IOS-XR, and these are the IP addresses of CSS1, CSS2, and CSS3, or are the our client, and this route reflector is the one. Okay, and let's show the configuration of ITP protocol which we have used to get the reachability between the loopback zero prefixes. So this is the router ISIS net ID configure, and interface are called in the ISIS. If you check the routing table, so the routing table we have a route for the all the CSS 1, 2, 3 loopback 0, and we have a route BGP coming from the customer prefix route also. And this is the thing is main. Okay, let's jump to the CSS1 CSS router. I will show the configuration. On the CSS3 router, so let me show you the first ISS ITP configuration which we have used to get the reachability between the loopback 0 addresses, so we can establish the BGP neighborhood. This is how we are configured. Let me show you the BGP configuration also. So this is the command we have to do. Normally what happens in the IOS-XR, you need to configure the route policy if you are getting the, if you want to change the route. Okay, I'm not using the route policy. I have configured this BGP unsafe. If you're doing, in the case of eBGP enabled, this command is required, else route will not be exchanged. You have to use the route policy in and out that you need to configure if you don't want to configure this command. And this is the eBGP neighborship with the customized device we have configured, and this is the config the same on all of the cell site router, all cell site router pairing with the route vector 1 and 2. This is the IP of route vector 1, this is the IP of route vector 2. And thing else, I think this is the only. So we have an route for the all three cell site router, and we have a route for the customer prefix. So you've seen the running configuration of route reflector and cell sites routers, and we have also seen that how the route advertisement happening from the eBGP to iBGP in case of BGP are with the different cluster ID, and we also seen that each cell site router getting a two copy of the route. Okay, so this like for COBGB 100 we have a two path, one from the RR1 and one for the RR2. So we have a two copy of one path with the one best path installed in the routing table. So in the next live, we will see BGP RR with the same cluster ID. We'll see what will happen.